Soldier Boy, tell them. Hey, I got this new dance for y'all called the Soldier Boy.
Alright, hello again everyone. Today we are going to be looking at the series circuit. Now there are some fundamentals that go along with a series circuit. Number one, we know that current anywhere in the circuit is the same, but voltage is different. So let's look at a series circuit today, simple series circuit, and we are going to look at how voltage, current, and power is distributed in the circuit. We have a source or a battery. We have two resistors. Sorry about that. Okay, we're going to call this resistor R1 and we'll call this resistor R2. Okay, we're going to give R1 the value of 3 ohms and we'll give R2 the value of 2 ohms. Our source, the battery, we are going to call it 10 volts. Okay? When I said that current anywhere in the circuit is the same, what I was saying is that if I were to put an ammeter here, and I were to put an ammeter here, or I were to put an ammeter here, these 3 ammeters will read the same value. That's what I meant by current is the same anywhere in the circuit. Now, in order to find the currents and different voltages in the circuit, the first thing we are going to need to do is to find the total resistance. Now, finding total resistance in a series circuit can be done very simply with a very simple formula. And the formula states that RT, which stands for total resistance, is equal to R1 plus R2 plus ... And ... means that if it went on to R3, R4, R5, it simply meant that you had to add up all of them. But for our case, it will just be R1 plus R2, which will be 3 ohms plus 2 ohms. And we have a total of 5 ohms. Okay? Now that we have found the total resistance for the whole circuit, I want to go ahead and redraw our original circuit. I repeat the source or the battery. I redraw a resistor, but this time I don't call the resistor R1 or R2. I call it RT. Why? Because it's the total resistance. Seeing that I have found the total resistance for these two, I could replace them with just one resistor, whose value is going to be 5 ohms. Our voltage still remains at 10 volts. Okay? Now that I have come to this stage, I could go ahead and use Ohm's law, which is V over I times R. And I want to advise that you spend time memorizing this. It will come in very handy, as you will find out eventually. This simply says that if I need to know how much current is flowing in the circuit, I simply block out what I don't know and I divide the voltage by the resistance. Okay, so for our case, it's going to be IT, which means the total current flowing in the whole circuit, is equal to V T, which is the source voltage, the 10 volts, over RT. Please note I did not put R1 or R2. I put RT. And if we were just to substitute in the values, it will be 10 volts divided by 5 ohms. And of course, we have the simple answer of 2 amps. So in this circuit, the total amount of current that is flowing is 2 amps. Okay? Let's, now that I know these, I'm going to just erase these. So we know the RT is 5 ohms, the IT is 2 amps, okay? Now, I would like to go ahead and find out what is the voltage drop across R1 and what is the voltage drop across R2. All right? Now, if I were to connect a voltmeter across this device and across this device, voltmeter, how much voltage will those devices read? That's what we're going to find out now. Again, we're going to be using Ohm's law, and we're going to say that VR1, which is the voltage across R1 resistor, is equal to, come back to our friend here, we wish to find the V. Okay? We're going to block out what we don't know and simply multiply the current times the resistance. Okay? So that's going to be IT multiplied by R1. Notice I did not put R2 and I did not put RT. I put R1. I substitute in the values here now. This is going to be 2 amps multiplied by 3 ohms, which gives us a total of 3 2s are 6, so it's going to be 6 volts. So for our circuit here, this voltmeter will read 6 volts. So once again, I'm just going to erase this very quickly because we need the space. It's kind of limited. VR1 is equal to 6 volts. Okay? Well, let's go ahead now and find out how much voltage is across this resistor, R2. So it's going to be VR2 is equal to IT times R2. And again, we're going to substitute in. We know that IT is 2 amps, multiplied by R2, which is 2 ohms. Okay, 2 2s are 4, gives us a total of 4 volts. So the voltage that this voltmeter is going to read is 4 volts. Okay? Now, I'll show you a little something here, just to check to make sure if your voltages were correct. If I were to add the voltage across VR1, and I were to add the voltage across VR2, which in our case is 6 volts and 4 volts, what is my resulting voltage? Isn't it 10 volts? 6 volts plus 4 volts? Simple arithmetic. Isn't it 10 volts? Which is our source voltage? All right? That's just a little double checking you could do whenever you do a problem like this. Once again, to find the power across the resistors, to find out how much power the resistors are consuming, we use a very simple formula. Okay? It simply says P for power is equal to V, which is the voltage, times the current. And in our case, that current will be IT. Okay? So this will give us, so let's look at the power that R1 is consuming. So PR1 is equal to the voltage that's across R1, which we found out to be 6 volts, VR1 multiplied by IT, which we found out to be 2 amps. And that gives us 6 volts times 2 amps. 6 2s are 12 watts. All right, because watts is a unit for power. How much power is consumed by our second resistor R2? PR2 is equal to VR2 times IT. And when you work that out, you're going to get 4 volts times 2 amps, which is a total of 8 watts. All right, and it's as simple as that. Thank you for your time, and remember to study hard.
Soldier boy tough. Hey, I got this new dance for y'all called the Soldier.